Arnold would like to purchase a toy for his child's birthday. The isosceles toy company claims that the number of weeks until delivery, x, is a random variable whose probability density function is displayed in the graph below. What is the expected time for the toy to be delivered? Because this is symmetrical, it's going to be the middle. So it's going to be 12 weeks. His child's birthday is in 13 weeks. What is the probability that the isosceles toy company will deliver the toy in time for his child's birthday? In other words, deliver it before 13 weeks or 13 weeks or fewer. So that's just going to be the area of this part. Now the area for the whole triangle must be 1. You can work that out anyway because the base here is 4 and the height is a half. But it should be 1 because it's a probability distribution. And then we want to take away this triangle. So that is going to be a half times the base, which we can see is 1, times the height, which we can see is a quarter. So that's going to be 1 take away 1/8, giving us 7/8. So it's 7/8, and the working obviously is up here. Given that the toy arrives in time for his child's birthday, what is the probability that it arrives at least 1 week early? So that's the probability of x being less than or equal to 12, given that x is less than or equal to 13. Remember, 13 is arriving in time. This is 1 week before that. So that's going to be the probability of x being less than or equal to 12 and x being less than or equal to 13, which of course becomes just x is less than or equal to 12, divided by the probability of x being less than or equal to 13. Well, 12 was the midpoint, and because it was symmetrical, that is just going to be a half divided by 7/8, which was the answer to the last part. So that is half times 8/7, and that gives us 4/7. Uniform Toys, a rival toy company, claims that the number of weeks until delivery of the same toy Y is a random variable whose distribution is displayed in the graph below. Which toy company should Arnold choose if he would like to maximize the chance that the toy will be delivered in time for his child's birthday, and why? So that means at 13 weeks here. So we can see the width of this rectangle is 5. This is going to be 4/5 or 0.8. Remember, for isosceles, that probability was 7/8. 7/8 is 35/40. This is 32/40. So the chance is less with uniform. So he should choose isosceles. And these calculations up here should be given as the y. Suppose that 5 people order the toy from Uniform Toys and let Z be the random variable that denotes the number of those people who receive the toy in 13 weeks. State the distribution of Z. We have a fixed number of trials, the 5 people, and a constant probability of success, the 0.8 that we worked out in the last part of the question. So Z is going to be a binomial with 5 trials and probability of success 0.8. What is the probability that 4 out of the 5 people receive the toy within 13 weeks? So that's going to be 4 successes and 1 failure. So we're going to have 5 choose 4 multiplied by 0.8 to the 4, that's the 4 successes, and 0.2 for the 1 failure. It might be better to look at these as fractions. 5c4 is just 5. And then we've got 4/5 to the 4 and 1/5 to the 1. So we have 5 times 4 to the power 4 over 5 to the power 5. And of course we can do a cancel here. So we have 4 to the 4 over 5 to the 4, which is 256 over 625.